Okay, no question. So there's something called when you develop a model, we've developed two models now, 5A, 5B. And this model, the differences is where the number of the predictors we are putting in, we are like nesting it, creating, making it more and more complex. And this is what we do is in research. You want to see, because you're looking for the best model, so that when you predict, you have validity, you are closer to the truth. So you have to look for the best model, and there are rules to finding the best model, and this is what we're exposing you to. Remember that it is important to consider variables in their different forms, since we don't know for sure what the true relationship are. That's what we are trying to explore. So what we want to do now is to create different forms of combination of the variables. Sometimes it's not just something that we just do out of the blues, but the availability, what data is available to you, one, and what do you know from your domain expertise about these variables will determine the variables that go into your models. So it's not just that you just do it randomly, you just mix the variables randomly. No, availability and what you already know already about the variables. So what we are doing here is to sort of categorize the number of children into categories. Either those that have 0 children into one category, those with 1 child, and those with 2 child, and those with more than 2. That means there's a category 0, there's a category 1, there's a category 2, and there's a category that is greater than 2. That means anybody that has 2, 3 children, 4 children, 5 children, they will be in one category. So that's what we are trying to do. We are trying to see, I could already understand that the person that wrote the code is trying to see, let's test whether number of children is actually, maybe a confounder or maybe an effect modifier in the relation between numbers of hours worked and mental stress. And if you look at this code, it's just calling out creating. This is creation child category. It doesn't exist. We are creating it. So it's like saying child category. This symbol is assignment symbol. Assign this child category, new child category variable under RDS. Pick RDS, the old data frame as we have it now. Pipe it into these commands. That means carry every RDS, and with this command that follows it, use it to manipulate anyone that affects it. Like you're saying, the whole of Nigeria. And we want people that are less than 50 years. We want to give them more than 50 years. We want to give them 5,000 if you're in this part of Nigeria. So more than 50 years is a condition. If you're in this part of Nigeria is a condition. So all these if else, that's what they are saying. They are specifying the condition that want to use to manipulate your RDS. And after manipulating it, this particular variable, they focus on the number of children. It's saying if the variable children include is dot not available, label all of them as NA. Hence, if the variable children include 0, matches 0, if you see any 0, label it as 0. If it matches 1, label it as 1. If it matches 2, that's what it's saying, label it as 2. Else, the final command is else, make it 3. That means any 0 is category 0, any 1 is number of children 1, category 1, any 2 is 2. Anything more than 2, if it's outside 0, 1, 2, please label it 3. That means all the 4s. Before I run that code, let me show you children. As you can see 0, 1, 3. 3 should go to 3. There should be more than 3. All these 4 will be labeled as 3 by the time I'm through with that code. You can see where the last column. So let's run that code. That's what this code means. And what do I want to explain? I don't know. If you don't understand this code, it could be explained. Hell, I wanted to show you something. Look at this. It's different from pipe. Pipe is percentage greater than percentage. This is not pipe. This is matches. We are saying if it matches pipe in pipe, just for you to know. You may not appreciate it now, but as you continue to learn out, just for open your mind that there are some differences. And this symbol, this curly bracket is just closing it. You use it to close a body of instructions. So I've run that code. If you look at my console, everything is fine, no error. It means that it has created this category, child category. So if you go back and check your data frame, it must be there. You could see it now, child category. You will only see 0, 2, 3, 0, 1, no, 0, 1, 2, 3. You cannot see 4, 5, 6 again. All 4, 5, 6 have been taken to 3. You know, for example, let's just check 1. Let's check any number of children that is more than 3. And okay, we can see now. This 4. So let me just, so if you scroll 71, 101, there, you could see it's not 3. There is no 4 again. We have to categorize. That's what we did there. So let's move forward. This is not where we're going. Then we now want to create a model that will factor in these categories. So we are creating another form of the model, testing whether the categories of in the number of children, the differences in number of children in categories actually impact, you know, the result we've seen before. And you could see specify the GLM, the function you want is a generalized linear model. What is our outcome? Severe mental health. Then what are our predictors? Hours work that we put before, gender, which is female, age category that was it there before? Age was, let me check. Was there age category before? Because if it's not there, okay, it's there already. It's in the original data set. But note something. I'm sure they've told you about data types in our character. Maybe I can say she's in a string is character, you know, she's a boy. If there's a data like that, she's a girl, you know, there's numeric, there's factor, and so on. But if I look at it, see my code, it's telling me it's a character. Each cat is character. And we want it as factors in categories. We want it to interpret this 35 to 39 years is not a string, it's in categories 30 to 40 years. We want you to break it down into 4 artifacts. So that's why we use as.factor. So you could convert any one data type to the other. You can say, let's say something like this, just for you to see quickly. Let's say which variable, hours worked. I can say hours worked. So to be sure, RDS, because you have to specify where it's coming from. Hours worked. You can do something like this. Is, you know, hours work is numerical, is quantitative. If you go back quickly, hours work, it will show you is numeric, so it's quantitative. I can say I want to convert it to as factor, the same thing. Just to show you this, the hours work that was numerical. If I do this, when I run this, it's going to change it to, I have to change it back. Let's run this quickly. And why I just want to show you why we did that. Now let's go and check our hours worked. Where you at? So these are hours work. Now check again. Do you see it? It's not factor. So you use as dot character, as dot numeric, as dot date. You can even convert to date. So not to destroy what we are doing, I have to change this because I will now stored our hours work as factor. I have to change back to numeric because it's a quantitative variable. You can see what I did. I just say, even though I manipulated the code already, it's already in R's memory. The hours work is now character. It's not factor. So I have to run this again and tell it, please convert it back to, and we'll go back to where we were before. So if you go and check again, hours work, it should be back to where we were. You will see numeric. Yep. So, and why I did all this is just to show you something that model 5C, I'm coming, please. What's happening? Model 5C. Okay, anyway, so if you mistakenly do something, you can undo, take you back till you get to undo. Yeah, okay, so I over deleted something. So this is what I wanted to delete. Are you guys with me?
Yes.
Excellent. So I just wanted to show you why don't we just put 8 cards? Each cat it was in character, so it has to be changed to factor, which is categories, as factor. Then plus children, which is the number of children, is already in categories. Then you have to specify where your data is coming from. Let's check children. Children is already numeric rather, yeah. So it's fine. But your age cat is in character. It won't be useful. And we want it to be in categories. That's why we use as factor. Specify where your data is coming, and the family of the GLM you want to use is binomial, and the link is still logit. So like we did before, I will just run it together. Summary will give us our entire result. So we run it. We've introduced 8 cards now here. So let's quickly look at it. You see it's bringing out all the categories of age. Then we can see if increasing age, middle age, or lower age is actually influencing or is not influencing, or whether it's children, number of children, or whether it's gender. And we can see again here from our p-values that even though the p-value is still really, really significant, is only hours worked is the association is not impacted by third variables, maybe age categories, gender, or even the children. You can see it. That's what we interpret here. We still reject the null hypothesis only for hours worked. We won't reject null hypothesis for other variables. Then there you can see, I will still come back to AIC. These are like model parameters. They have meanings too. Really, they all have meanings. Then, yeah, if you want to see, I think we don't need to check for our odds ratio. We will get roughly just like what we got. What we are trying to demonstrate here is that does age categories, does difference in age, does it, we're trying to adjust for it. Does it have any effect, on the relationship that we are seeing between hours worked and mental health? So that's model 5C. We can, create a different combination of our variables again to ask questions. If you look at this, we are saying now child categories. Does the number of children, in terms of categories, actually impact? What we did here is children number in total. We did not break it down. That we just said children, number of children as a continuous variable. But we could say, please break it down for us. And you could see that we only get one coefficient for children, impact of children as a whole. But what we are seeing, who knows, maybe if we separate infants or we separate elderly children, elderly people, maybe they differentially impact mental stress. Who knows, maybe older people are likely, by virtue of their age, likely to be mentally stressed compared to younger people. And that's why, it's children we are looking at. Maybe people that have 5 children or more than 3 children are likely to be mentally stressed because of additional stress of taking care of all the children or worrying about their future than those that do not have children. That's what we are trying to explore here in this model. Those are the kind of questions we are trying to explore. And I will run the model again. The only thing that is different now is the child category. Running it again quickly and looking at our results, we could see again that we have to reject the null hypothesis for children categories, for gender, and that hours worked is still significant. It didn't affect the relationship like that. But what we may see, we may even try to see if the estimation, the quantity of relationship is affected. Maybe instead of 0.95 that we are seeing, maybe we'll be seeing 0.8. That is some numbers. So let's just do, it's not in the code, but we can do that. Let's quickly copy instead of me typing again because of time, so that we can finish in 10-15 minutes. So this is what we need. Yep, this is what we need to get our odds ratio. So we come here. We've passed all these ones. We here now. Yep. So I can write a separate code just under here. So if you want to write a code, Control Alt Insert. So I can just put my code here. I could lump it under those ones. It's the same thing. But now don't forget, you have to change your model. Which model are we interested in? What's this model tag? This is model 5D. So you have to change it to get this result. Because if you put 5, if you limit as 5A, how we go, it will give you the odds ratio of the first one. So this should be fine. You can run it now. Something is wrong. Something is wrong. So it should be minor. 5D. So what is wrong? Config this. It should work. Just a minute. Let's see. Something must have been wrong somewhere. But the result is there, but something is wrong. So the odd ratio does not make sense. It's so okay. It is 0.92. Yeah. Do you agree with me? Look at the odd ratio. This is 0.92. Yeah, for hours work, 0.92. Maybe that's why, maybe it doesn't make sense. That's why it wasn't included the other time. But the important thing to point out is that the child categories based on this p-value does not have any, maybe it doesn't have any confounding effect. We've adjusted for it. It doesn't affect the relationship between hours worked, the association between hours worked and mental stress. That is it. You understand? That's the point here. And we should not waste time. It's fine. You could leave this for people like me to look into. It did not convert, maybe data issue. Okay. So any question? Is that clear, guys? Hello?
Hello?
Yeah. Is that clear? Is that interpretation clear?
Yes.
Okay, good.
Yeah.
So we could see, we are just repeating what we've done before. That child category does not seem to have, some people have left. It's fine. We'll soon finish. It's a long walk. So the next thing is AIC. That's a Koike information criterion, is used to select the best of models. There are ways to interpret it. Because of time, this command is just saying, please give me the AIC value for these models. If you run it, it's going to give you the AIC value, which is this. The lower the value, the better. You can see for model 5A, because what we want to do is to select the best model. That's what we are trying to do. And I will start thinking of model C. Does it mean that that's the lowest value? Does it mean it's the best value? Another test that we can use to help you select is the log of likelihood test. The likelihood ratio test is called likelihood ratio test, and you have to use a package called LM test, and that's what I'm just running. When I told you before, when you use library, you're just calling that package. You can view the log likelihood of each model you want to compare. So now we've about 5 models. Now how do we know what model is the most reliable? We give us the best fit to what our data is saying. Then you just say log like of the model. You can easily view it is a number. There is a calculation that is used with this number to help in selecting the best model. It may be a bit above what you should be bothering yourself about, but just for you to know that you can do that. And there's a test when you want to compare the models, for log of likelihood ratio test, it's called LR test, log likelihood ratio. We've done log of likelihood, which is what these values are. You do a ratio. The two models must have been run in the same exact data sets. If there are missing data in one of the covariate, the log of likelihood ratio will not give result. We are trying to show that if you want to compare log of likelihood of two models, trying to know which one is better, they must be from the same data set. This will not give you answer because model 5A and 5B, if you go and explore, they are different. There are differences in the covariate. They are not from two exact data sets. We started manipulating after 5A. We started adding to the hours worked. Then you can do the same thing for C and B, and you can see you got results because they included the same number of covariates, both 5C and B, children, gender, it is there, or like A, that is just. So that's what this is trying to tell you. Now you can do a log of likelihood ratio test, and you can see the values, log of likelihood, minus 62, minus 68. To interpret this, you have to know which of the two models is nested. I'm not sure how much you can appreciate all these terms, but just it's good. If you hear it for the first time, you may hear it again, maybe in a proper class. I don't know how much you've been taught, or which of the models is more complex to the other. That is, which model contains the other. If the two models have different number of covariates, the model with fewer covariates is simpler. That means model A is simpler because it has just one covariate, numbers of hours. It's also nested if certain blah blah. Okay, if you have a continuous versus categorical variable, the model with continuous is simpler. So which model will be simpler? Hours work is continuous. If you have like a model that has only child category, that is categorical. It is considered complex. So you have to just know all this. Then if there's interaction, I'm sure you will have thought about interaction. Interaction is when you multiply two variables to see if one variable directly, is impacting the relationship of the other variable with the outcome. So that's what we call interaction. So if you see an interaction terms in one model, then it's simple. I'm not sure if you can really appreciate this. Then to really choose your model, the next thing is you look at the p-value. If the p-value of the likelihood ratio test is significant, then the complex model is better. If not, the nested model is better. So for us, let's check our final model. If you follow this rule, is a simpler one, because the p-value of our likelihood ratio test is not where is that? We did one here, model 1. No, this is model 5C. Let's check model AB. Why is the final model here? Okay, let's run this. Why is the final model 5A? We've done this before. So why should you choose the first model? That's what all this is trying to explain, how you choose which of the model is the best for you. So if you look at this, you have to apply these rules against all the models 5A to D to now select which model is the best for you. And we could even see from our results that the additional variables does not really counteract the result we are seeing in the first model in terms of hours worked and relation between the hours worked and the mental health outcome. I've not given this serious thought. I've not looked at it. Time is gone. But you have to select a model. You can also look at it, weigh all the 5 models against the criteria that we put here to select your best model. But if you can use AIC, you can use log of likelihood ratio test, which you demonstrate to select your model, because you have to select a model to now start predicting if you are doing a prediction or to reach your conclusion and interpret your findings. So this, if you go by this as our final model, we are saying that for every unit increase in hours worked, there is a 4% less likelihood of developing severe mental health stress. That's our conclusion. That's our conclusion. Yeah. I want to quickly do something before we go. We've come to the end. Just give me 5 minutes of your time before we go. I know it's a long lecture, and there is no way to go around our lessons. Okay, sorry, let me go back here. Final model. I just want to do something to the final model, not AIC. not this, not this, not this. This, what do I want to do to it? Sorry, I want to change the hours worked to the categorical stuff, to the hours GT80. Let me just copy it. Hours GT80, the one that is in categories. These are model. So let's run this. Let me change this. Let's see what it gives us. Hours GT80X. It's 80X I would do. 80X. So let me see. So you could see, let's go to, let me run this quickly so that we get the hot ratio and we interpret it. You could see this is a category. These are two categories. We are using those that work less than 80. You can see greater than 80. Those that work less than 80 is the reference. And the p-value is significant, meaning that there's a relationship between, there's a difference in terms of the outcome in those two categories, greater than 80 and less than 80. And with this, you can see we are getting a different odd ratio. So those that work more than 80 hours per week, resident doctors that work more than 80 hours per week are 71% less likely to develop mental health stress compared to those that work less than 80 hours per week. Does that make sense, guys? I think that should be the final thing.
Yes.
Thank you so much. So, so you could see that we are using the continuous numbers of hours as a very continuous variable. Now I change it to quantitative so that you can appreciate that. Okay, so let me see if there's any other thing. I think we've come to the end. Oh, it still remain quickly. So, okay, you may, if I don't know, I'll ask you guys if you have time. So the only thing left here is that interaction. I'm sure you may want to see whether odd ratio varies with the level of a third variable. You know, we talk about confounding. That's why we're adjusting for other variables. Now, there could be interaction. And the only thing I want to show you quickly is that look at this. Hours greater than 80 is gender interacting with the number of hours work. You know, those are two predictor variables. And this is how you do interaction. You use more like you're multiplying. The computer will multiply it and see if there is an interaction. And you can use, if there's a category to, you can use that like an effect modifier. You will see differences in the odd ratio based on the categories of that, you know, modifier. So this is interaction. And if you run it, we'll see, you still look out for your p-value. Look at, you know, you can see the interacting and it's not significant. You will rule out 0.716 is far more than 0.05. So I already know I won't waste my time. There is no interaction. That's what you say. That gender is not interacting with the relationship we are seeing, hours worked and mental stress. That's what it means. Well, what's this? Let's look at this model. I think this is basically the same thing. This is just
this number of Fisher scoring. This Fisher scoring, I don't understand. The number of Fisher iteration.
You know, I don't know really, but for my iteration, there is something the computer does where, because it generates all these figure randomly, there's something called iteration. Like it use different combinations. It's back end stuff. So I would just say you should not bother. But I don't know exactly. You could check it up. But what is really important is your p-value, your estimate, maybe your standard error. You don't even need it. So what you really need is your p-value, the coefficient, and converting into odd ratio. I actually don't know what number of Fisher scoring iteration is. I don't know. But I can tell you that it's not something that you should bother yourself in terms of interpreting your result. Maybe a statistician may really bother about that. But I know that the simulation that the computer is doing, that the software is doing, it does it multiple times. Sometimes it does it 100 times to look for the best fit. You know, it mixes the number, maybe from 10.01 change to 10.02, something not significantly different, then combine it and see which one gives the best. It's software stuff. I don't know. So I would tell us to just leave this. It's just another combination of our predictor variables, hours greater than 80 and female, different combination of our predictor variables, is going to give us something like one of the results. And this is doing it. This one is just saying that these are two models and they are doing the likelihood ratio test. You want to select the model. You are comparing these two models. That's what this is doing. So if I run it, we just get roughly the same thing. And if you look at p-values, see the same thing. Gender is not significant in this model. And if you run this, so basically you are getting values, and this is just helping you. These are all analysis you run to select the best model. This is what you should know about this. There are formulas to it. Log of likelihood, if you remove it, if it's more than -2, something like that. But I will not want to. You can read it, but it's something that you layer up much later, just to select your model. Then we've been dealing with odd ratio. Some people talk about risk ratio is more intuitive, that we can want a risk ratio. When you look at risk in one category, in one group, compared to you layer it, if the risk is more than one, you know that, oh, there's higher risk in this ratio. So we can also use our GLM to calculate the risk ratio. But what we change now is that even though it's binomial family we are using, because our outcome is in two categories, you still have to use binomial. But you now change it to, instead of logit, to log. Logit is simply the same thing as log of odds. Log is just log. That's what log means. So log of odd is logit. So this one is just like you have to change it. That's the only thing. If you want to get risk ratio, that is the only difference. Yeah. Instead of getting odd ratio, you are getting risk ratio. And you get your estimate again. You can see it. These are your estimates for gender. And you convert it by exponentiating again, the same thing. The only thing is that we've changed the family description so that you get risk ratio instead of odd ratio, because the definition of odd is different from the definition of risk. Odd ratio compared to risk ratio is just that. That's the only thing. And there's a way the software can do it, and that's what we've done. And if you look at it again, we change it instead of odd ratio to risk ratio. So you can get your risk ratio and you must be able to define it. So if the risk ratio is saying 0.73 and our reference is male, that means risk ratio in female over risk ratio in male is equal to 0.73. That's what it means. That means in this case, if you look at the model again, the only thing we are looking at is we are looking at hours in relation to gender. This is just an example. Our outcome here is no more mental stress. Our outcome here is now hours. That's hours GTAT, the two categories compared to the two gender categories. Now we can say this is just telling us that is there a difference in numbers of hours worked by male and female? And if you go by these p-value, there is no difference. Because the p-value is greater than 0.05, we cannot reject the null hypothesis. And the null hypothesis is there is no difference. That's what this means. Even though the RR is showing difference, but it's not statistically significant. And even if you look at your confidence interval, it has crossed 1, 0.4 to 1.2. You already know that there's no statistical significance here, even though this is suggesting that maybe female gender has lower, are more like, probably work less because we're looking at hours as our outcome variable. The last point, we want to calculate risk ratio. You can use binomial, but you change the specification from logit to log, or use Poisson distribution. Poisson is usually used when the outcome is in cants. The outcome for the logistic regression is binary outcome. This one is in cant. He said the log binomial model fails to convert. This is the advantage of, if I want to use risk ratio, there are two methods. You can use Poisson, you can use log binomial instead of logit binomial. In that case, an option is the log Poisson model. Log Poisson tends to give us larger p-values, wider confidence. Don't bother about it, just to show you approaches that we use. So we create an object called logfish to store our model. So it is hours and gender that we are trying to see now. We change the family. We are using Poisson now instead of binomial distribution. We are using Poisson. These are statistics, and the link is log. It's not logit, because what we are looking at is risk ratio, not odd ratio. So if I run this, see, is there a difference in the numbers of hours worked in according to gender? The p-values is not significant. I already start saying no difference. You know, gender will not really say that. If you want to see your risk ratio itself, exponentiate it again. These values, I can interpret it, but look at my confidence interval. It's not significant. So I can't say females, you know, work more or work less rather in terms of hours than male. I can't say that the risk of working more is higher in female, is less in female than male. No, you can't say that because it's not significant. I think that's where we end. So my last statement is that we've looked at chi-square, we've looked at logistic regression. There are instances where you want to use a logistic regression over a chi-square, when you want to really estimate your relationship, when you want to address confounders, things like that. You know, you have to use your logistic regression. And for logistic regression, the outcome variable must always be a binary outcome. That is really, really important. I would like to stop here. If you have a question, I can answer in 5 minutes, you know, and I will say, don't be dismayed. How is like this? The little you can learn, continually build on it, watch more YouTube video, revise, go line after the line. If there is a command that you try to work on your own, it doesn't work, send a mail to me or to Jibola. We'll be happy to help. And that is how you can learn. From my experience, I learned how on my own. They guided me. I had introductory sessions like this, then I started building on it. It's intuitive. You continue to, and I'm still learning how. I would like to stop there. Are there questions? It's a long time. It's a long day.
Thank you very much, sir. Thank you very much.
Ozioma, any question? And thank you too for staying this long.
Thank you very much. No, like you said, it's intuitive, so we'll continue to learn.
Mashoud, any question? And Amid, any question? Then if there are no questions, okay. Thank you so much, guys.
No,
and,
no question. Thank you very much.
Thank you so much. And
yeah, thank you so much for your time.
And that please just follow the advice I give. You know, start learning on your own. Start reading. Within a short time, you find out that your proficiency is increasing. The first thing that you have to acquire is confidence to move around. By the time you have confidence, forget about the codes. You will understand this code with time, and nobody cramps them. It's just for you to understand. There are places you could go and pick it even on R and just adapt it to what you want to do. Okay, I'll stop here and say bye-bye to you all. Enjoy your weekend.
Bye-bye. Thank you for your time.
Bye. Thank you.
Bye. Bye.